This video is on 3D straight line. But before starting with straight line, we have to know certain basic things, that is direction cosines and direction ratios. So that's the thing I'm starting with. So first is direction ratios and direction cosines. Now suppose this is my 3D space bounded by the three axes. If you remember, I showed you the 3D space with the help of a model in class 11. So the same space I'm drawing here. So these are the positive direction of the axis. So obviously the space that is in front of you is the first octant. You know there are 8 octants. Now one thing is you have to remember that this is 3D. So obviously we are doing it on a 2D screen. So you will have to use your imagination a lot. Now suppose there is a straight line passing through the origin, and the line is lying in the space. Just for the sake of convenience, imagine the room you are sitting in, that is the first octant. So you can fix the lines of the along the floor and the roof and the wall as XYZ, as I showed you in class in 11. So imagine that the line is suspended in the space passing through the origin. So I'm drawing such a line. So obviously this line is in space, okay? So suppose this is the line, let me name it AB. So why am I taking it through origin? Now it is not necessary. It can be any line, not even passing through origin. But then if you displace it, keeping it the line parallel to itself, you can make any line pass through the origin. So ultimately it boils down to passing through origin. So I am taking the line already passing through the origin. Now let us suppose let alpha be the angle between OA. Now, remember one thing, when you are doing 3D, we have to assume that we have done the vectors before. So this is a combination of vector and 3D. So I'm doing the video on 3D. Later on, I'll do on vector. So right now, when I say OA, it is the vector OA, that is in this direction from O to A. Okay. Now, alpha be the angle between OA and positive x-axis. Beta angle between OA and positive y-axis, and gamma angle between OA and positive z-axis. If we want to show at all the angle, if we want to, we can try. Say alpha is between positive x-axis and OA. That means this is alpha. This is alpha. Okay. Similarly, if I draw all beta gamma, it will become very clumsy. So I'm drawing only alpha. So alpha is the angle between the positive x-axis and OA, direction OA, not OB. Okay, OA. Or we could write OA or BA. That is, the direction is mean. That is this direction towards A. Now, if we take these three angles, alpha, beta, gamma, like this, then These are called direction angles. Direction angles of BA or OA. Now, let now we are introducing three new symbols. L, I'm going to call it as cos alpha, M cos beta, N cos gamma. So remember, this what we are doing now is somewhat similar to the concept of slope in 2D geometry, where you have seen that angle of inclination, since there are only two axes, so angle of inclination theta was between the line and positive direction of x-axis. So, and obviously the other one will be 180 minus angle of inclination, that is 180 minus theta. That's it. But since it is 3D and there are three axes, so we cannot use the slope. So the idea of slope has been replaced by direction ratios and direction cosines. So there was only one angle of inclination theta because the other was 180 minus theta. But here we cannot do that. So we need three different angles, alpha, beta, gamma. And the cos of these angles, L, M, N, they are called direction cosines. Then L, M, N, they are called direction cosines. In short, this is of BA. Okay. So that is that. First of all, this is the definition of direction cosine. Remember, this is absolutely important. Positive direction of x-axis, positive direction of y-axis, positive direction of z-axis. Now, if you what happens is, if let us consider the angle alpha. Alpha is the angle between the line and positive direction of x-axis. So if I draw the negative direction of x-axis, then you know it will go. It will be beyond. It will be going outwards the screen, backwards. So this is x dash. So then what happens is this angle will be 180 minus alpha, right? This will be 180 minus alpha. So what happens is, here we have found actually the direction cosines of BA. Direction cosines, sorry, not this one, LMN. They are direction cosines of BA here. Direction cosines of BA. Now, if you choose a different vector, opposite vector of the line, that is, if you choose the vector AB, now let us see what will be the direction cosines of AB vector. Okay. Now, first is direction angles. Direction angles of, so it was BA before, so now I am taking AB. That is in the direction of B. So if you take this, then what happens? What are the direction angles of AB? It will be 180 minus alpha, 180 minus beta, 180 minus gamma. So I have shown only one in the picture. So direction angles of AB will be this. Therefore, direction cosines of AB will be cos 180 minus alpha, cos 180 minus beta, cos 180 minus gamma. That is, this is minus cos alpha minus cos beta minus cos gamma. So that is minus L minus M minus N. So what do we see? That, so finally what do we see? Conclusion. Any straight line in space has two sets of DCs. If one set is called L, M, N, then the other will be minus L, minus M, minus N. Okay. So it is not necessary that, for example, here we have taken BA direction as LMN and AB as minus L minus N. So that is not necessary that it always has to be like this. No, the thing is, if any in any one direction it is LMN, then in the opposite direction it will be minus L minus N minus N. That is the thing. So this is what we mean by direction cosines, which is somewhat similar to slope of a line. Okay. Now, these direction cosines, these they have a very important property. Very important property of direction cosine. Note, no matter what the line is, L square plus M square plus N square will always be equal to 1. This is a very, very special property of direction cosines. Okay. Next, we come to the definition of direction ratios. So that's it for direction cosine. Now let us see what is direction ratios. So suppose I name number this as A, direction cosine. Now we come to B, direction ratios. Okay. Now let's see what is direction ratio. The definition is any three real numbers proportional to uh, element proportional to LMN are direction ratios of the line. Of the line means the line whose direction cosines are LMN. So any three real numbers. Okay. So if I want to write it mathematically, then let A, B, C be three real numbers such that কি বলেছে they are proportional, right? So কি property, what is the property satisfied? A by L proportional to element, so B by M equal to C by N. Then ABC are called direction ratios. So if this property is satisfied, then we will call A, B, C direction ratios of the line. Right. Now, next thing that we want to, here one important note is, just as you have seen that for any straight line there are two sets of DCs. So for any straight line, how many sets of DRs will be there? For any straight line, how many sets of DRs exist, right? This is called a set. This is a set. This is a set. Okay, we write them like this. So how many sets of DRs will? Obviously, the answer will be infinite, right? So the answer is infinite. Infinite. Why? Reason is very simple. If ABC are proportional to LMN, then you multiply ABC with any real number, say K. Then KA, KB, KC, where K is any real number, with they will also be proportional to LMN. That means KA, KB, KC, they are DRs. So KA, KB, KC, they are DRs. And since K is any real number, so the number of sets of DRs will be infinite. So, so this is the definition and property of direction cosines and direction ratios of a straight line in 3D space. Next, what I am going to do is that if your DRs are given, next topic is if A, B, C is one set of DRs given to us, then how to find the DCs of the line, direction cosines of the line. That's the next topic. Okay. Now, we will stick to the symbols. It is conventionally done so. That is, LMN used to denote DCs and ABC used to denote DRs. So I'm not going to introduce them again. So since ABC are DRs, we already have A by L equal to B by M equal to C by N. Suppose this common value is lambda. Say, obviously, lambda is a real number. Now from here, L equal to A by lambda, M equal to B by lambda, and N equal to C by lambda. L, M, N are DCs. Now since we know that there is a property of DC that L square plus M square plus N square is always 1. So obviously, if we now plug in the values of LMN and let us take 1 by lambda square common. So you have A square plus B square plus C square equal to 1. Okay. So from here you have A square plus B square plus C square equal to lambda square. So lambda equal to plus minus root over A square plus B square plus C square. Right. So now let us see what are the values of LMN. Remember, your ABCs are given. These ABCs are given to us. Okay. So now what is my L? You can see here L is A by lambda. So L equal to A by lambda. Now lambda has two values, plus minus. Now remember, when you take the plus value, you take plus for L, M, N, all the three. When you take minus for LMN. So one set of LMN will be taking the positive value of lambda, A square plus B square plus C square. M will be B by positive root of A square plus B square plus C square. And N will be C by positive root of A square plus B square plus C square. So this will be one set of DCs. And the second set of DCs, let us call them L dash M dash N dash. So that will be A by, this time, negative square root of A square plus B square plus C square, M dash, that's it. So in the beginning only we saw that for any line in space there are two sets of DCs. So here we learned two things. That one is, uh, if a set of DRs are given ABC, how to calculate the DCs, and also from the calculation we see that there are two sets of DCs. Next topic that we will do is, uh, suppose 2 points are given on a line. There two coordinates of 2 points are given which lie on a line. Uh, how to find the DRs and the DCs of that line? Okay, so given 2 points, say A coordinates x1, y1, z1, and B x2, y2, z2. So what we want to find out is, first is DRs, direction ratios, of AB. So that is x2 minus x1, y2 minus y1, z2 minus z1. So remember, this concept is again similar to finding slope of a line in 2D where 2 points were given to you. So you remember the slope was y2 minus y1 by x2 minus x1. So I'm not going into the derivations, they are quite complicated in 3D. So just giving you somewhat a similarity between the two concepts. So DRs will be given by this. Okay, so these are the DRs, and let me first give you the formula for DCs, and then I'll explain a little bit. So it will be, DCs will be x2 minus x1, that is the corresponding DR, by distance AB. Now what is AB? What do I mean by this? This means distance between A and B, which you know is given by the formula from class 11. You know distance formula in 3D: x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. This is the distance between A and B. So the corresponding DCs will be there. So first DC is this. Second DC is second DR by distance between AB, and third DC will be the third DR by distance between A and. So this is how we calculate the DRs and DCs if we don't know alpha, beta, gamma. Instead, we know 2 points on the line. Now, in the next portion of the video, we'll be doing some sums on this theory portion. But you will see some green writings on the screen. Please ignore the writing in the green ink. I was trying to correlate 3D and vector, but then I decided against it. So let's keep it purely 3D. So directly go to the sums. Let us do some sums. I think that will help to get the concepts cleared further. So let us do some sums. Let's start with simple sums. Say, I think these are in your NCRT. Uh, okay, DRs of a line are given to be minus 18, 12, and minus 4. You have to find the direction cosines. You have to find the direction cosines. Now, direction ratios are this, uh, which can also be written as, we can further reduce it, right? Dividing it by 3. So, minus 9, 4, and minus, sorry, it is minus 4, so 2, 2, sorry. You have to divide it by 2. Common factor among them is 2. So, minus 9, 6, and minus 2. Because remember the definition of direction ratios, they are proportional to element. So if minus 18, 12, minus 4 are proportional to element, so are minus 9, 6, minus 2. You can always cancel out the common factor too. So always we first reduce the DRs to the minimum values. So these are the DRs. Now we'll calculate this expression, that is minus 9 whole square plus 6 square plus minus 2 whole square. So that is, I think, 11. Which one? Yes, it is 11. So, therefore, answer DCs are answer. DCs are. So, one set will be minus 9 by 11, 6 by 11, minus 2 by 11, or 9 by 11, minus 6 by 11, 2 by 11. So this is how we calculate DCs from DRs. Okay. Next sum. So 2 points are given to us. A, suppose minus 2, 4, minus 5. B, 1, 2, 3. So you have to first find DRs and then the DCs. This is the question. So again, according to formula, the DRs will be, if you consider this as x1, y1, z1, x2, y2, z2, so 1 minus minus 2, so that will be 3, 2 minus 4 minus 2, 3 minus 2 I 8. So these are the DRs. So these are the DRs. This is one set of answer. And the second is to calculate DCs. Again, you have to find the value of, that is mod AB, that is distance between A and B, uh, that is 3 square minus 2 square plus 8 square, that is equal to root 77. So DCs will be 3 by root 77 minus 2 by root 77, 8 by root 77, or, so this is one set, or actually you can give one set only as answer. It is not necessary every time to give two, especially these are 1 mark sums. 3 by root 77, 2 by root 77, and minus 8 by root 77. So these are the DCs. when 2 points are given. Okay. Number 3, uh, a line makes 90 degree, 135 degree, 45 degree with positive x, y, and z axis respectively. Find the direction cosines. Okay, so these 90, 135, and 40, they are nothing but direction angles. These are direction angles because they are with the positive direction of xyz axis. So these are direction angles. So cos of them will become my DCs. So answer, the DCs will be cos 90, cos 135 degree, cos 45 degree. So if you calculate the value, 0 minus 1 by root 2 and 1 by root 2. So that's the answer. So you sometimes get short questions like this. What are the DCs of, say, z-axis? DCs of z-axis. Now z-axis, what are the direction angles of z-axis? It makes angle 90 degree with positive direction of x-axis, 90 with y-axis, and 0 degree with itself. So naturally, this implies that the direction cosines will be cos 90, that is 0, cos 90, that is 0, and cos 0, 1. Similarly, DCs of x-axis will be 1, 0, 0, DCs of y-axis will be 0, 1, 0, and so on. Okay, now let's do another sum. This came in 2017 in the board exam. A line makes 90 degree and 60 degree respectively with positive x and y axis. Okay. Find the angle it makes with positive z axis. So suppose gamma is the angle it makes with positive z axis. Therefore, the DCs are LMN, they are cos 90, cos 60, and cos gamma. So that is 0, root 3 by, cos 60 is half, and cos gamma. Okay. But we know that L square plus M square plus N square is always 1. So 0 square plus half square plus cos square gamma must be equal to 1. So from here you get cos square gamma equal to 3 by 4. So cos gamma equal to plus minus root 3 by 2. That means gamma is either 30 degree or 150 degree. So these are the two values of gamma. But uh, we always when we take the angle between two lines, when remember in 2D11 we learned that when we are asked to calculate angle between two lines, there are actually two angles, one acute, one obtuse. So if we always find the acute one, usually conventionally, and then the obtuse is obtained by 180 minus the acute. So here actually we don't know whether it makes 30 degree with the positive direction of x-axis or 150 with the positive direction of x-axis. But if conventionally we can write that therefore the acute angle the line makes with positive z-axis is 30 degree. So that this is just pure convention, because whenever we are asked to find, say in 2D, if you go back, if there are two lines, then basically there are two angles between the line. One is this, say alpha, and the other is this, say beta. So one is acute. If one is acute, the other is obtuse. So if the question is a short question like find the angle between these two lines, you give the value of alpha. And if it is more than 1 mark, then usually I tell my students to give both the values, that acute angle is alpha and the obtuse angle is 180 minus alpha, which is beta. Similarly here also, the angle between the positive direction of z-axis and the line could be 30 or 150. But if we take the acute value, then it is 30. That's the thing. So basically this is the main answer. And one last sum we'll do on this topic, and then we'll shift to next topic. Find the disease of a line that makes equal angles with the axis. So let alpha be the angle. Since it is equal, so all the three direction angles are alpha. So that means my L, M, N, each is cos alpha. So L square plus M square plus N square equal to 1. So from there we get cos square alpha equal to 1/3. So cos alpha equal to either 1 by root 3 or minus 1 by root 3. Right? So uh, therefore DCs of the line are either it is 1 by 3, 1 by 3, 1 by 3, or the second set will be minus 1 by root 3, minus 1 by root 3, minus 1 by root 3. That's it. So these are some very simple short questions on DRs and DCs. You get only short questions on this topic. Next, we'll pass on to the next topic.